This is 7-6, which is where logarithms are finally starting to get fun. This is actually some of the, I don't know why, but I just really enjoy doing stuff like these, the rewriting the bases. But I like numbers, all right? What I'm going to do is I'm going to choose a common base of 6. I know that 36 and 1/6 are both powers of 6. 36 is a 6 that's squared. We got 5x plus 2 still in the exponential space. And 1 over 6 is 6 to the negative first, and you still had that 11 minus x in the exponential space. And this would have been taught to you, but a base to the x equal to a base to the y implies x equals y. As long as the bases are the same, the exponents have to be equal as well. So if I distribute here, I have 10x plus 4 equal to negative 11 plus x. X is on one side, numbers on the other. If I move that x on over, I'd have 9x. And I do negative 4 minus 11, I would get negative 15. And my x value is negative 15 ninths, which reduces down to negative 5/3. A lot of smart kids can figure out what these are without actually doing the algebra, but as good as I am with numbers, I don't think I would have looked at that thing and figured out that x was negative 5/3. But I'm just going to check it. I'm going to take a negative 5 over 3. I'm going to store it to my x. I got 36 rooftop 5x plus 2. The left-hand side is that funky scientific notation. Check the right-hand side. They're the same. That's the deal. You were looking for equality, and they were. At number 4, it's actually a lot like number 3. Here I'd choose a common base of 5. 25 is 5 squared. And just think about, I'm also using that property here, x to the a to the b. That's what I'm using. I'm using properties or rules of exponential functions. And I got the 10x plus the 8 still up there. 1 over 125 is 5 to the negative third power. You're supposed to know your cubes. You are. You just do the rewrite. So if you understand your cubes, problem like number 4 is pretty easy. 20x plus 16 equal to negative 12 plus 6x. X is on one side, numbers on the other. 14x is negative 28, and the x value is negative 2. Ta-da! Man, I did a lot of these. There's number 5, also bolded and underlined. I would choose a common base equal to 3. I've seen kids do this with 9, but then you introduce that half fraction, so why mess with that? 3 to 3x minus 7 equals 81 is 3 to the 4th power. Bases are the same, drop them. 3x minus 7 is 48 minus 12x. X is on one side, numbers on the other, same old thing. 15x is 55. It's going to be a fraction. X is 55 over 15, both divisible by 5. That's 11/3. All right, these are logarithms because you just can't answer these. We got 5/10 of x, take away 2500 is equal to 4. The first deal is to isolate the base. So I'm going to have that 5/10 of x, which I'm going to rewrite as a half for some reason, because I guess because I feel like it, equal to, I don't want to say 4.25. And I don't know that you should either. I really don't. What would that be? 17 quarters? I feel like that's 17 quarters. I don't guess it actually matters on this one if you do 4.25. You could. Anyways, I don't like to. Anyways, now the goal here is this looks like something you're supposed to have memorized. It looks like a rule. And I'm going to write the rule backwards. A base with an exponent equal to anything has an inverse of a logarithm of that base whose answer over anything is equal to e. So here's my pieces. That's the base, that's the exponent, and that's the argument. And I'm just going to go ahead and take care of it. I'll have a log whose base is a half. Its argument is 17 over 4, and I can't answer that logarithm. I don't know what power of a half creates 17 over 4. And that is equal to my x. Now I'm going to use change of base. Log base b, argument a, is the natural log of a over the natural log of b. All right, cool. This becomes the natural log of 17 over 4, sitting over the natural log of a half. That'd be equal to x. I'm going to write something down because I've seen the state do this to you. This could be the natural log of 17, take away the natural log of 4, over the natural log of 1, take away the natural log of 2. Boy, that would throw a lot of kids off. I promise you the same. And I don't know that we've even talked about this rule yet, at least other than a form quiz. But your form quiz says something along the lines of log AB. I'm just going to simplify it to log of A over B is log A minus log B. And that's where this is coming from, okay? That's where it's coming from. But anyways, I'll show you their equivalent because I swear they are. Let's see, math, number, numerator over denominator. Natural log is 17 over 4, sitting over the natural log of a half is that little funky decimal. Now I showed you an equivalent statement. I wish the state wouldn't do this just because so many kids don't understand logarithms, but they do it. And they're the same thing. They have the same numeric value. This is actually a preferred answer. Like, when you take upper level math, that's how you're supposed to write it. It really is. Anyways, there's your x value. X is about negative 2.0875. Now we got a second one in here that's bolded. Number 10, negative 3e to the 2x plus 16 is 5. And again, what we're going to do is we're going to isolate that base. So I'm going to subtract the 16. That's going to give me a negative 11. And I have not isolated the base yet. I divide out that negative 3. So e to the 2x is 11 thirds. So again, here's a base, here's an exponent, and here is an answer. So I'm thinking about that. I'm going to write it down again. A logarithm base b, argument a, equal to e is equivalent to a base with an exponent equal to a. And I just use that. I'm going to read it from right to left. This becomes a log whose base is e, its argument is 11 thirds, and it must equal 2x. A log base e is a natural log. It's understood. A lot of kids like to go push buttons right here. Save that for later. All right. This is the natural log of 11 thirds over 2 is my x. And again, you need to be aware that this could be written natural log of 11 minus natural log of 3 over 2. It could be. They're the same. Natural log, oops, I'm just going to do this in two parts. Natural log of 11 minus natural log of 3. Enter, divided by 2. There's my decimal, 0.6496. Always 4 decimals. Didn't do 13, moving on to 14. 14's old. Suppose, well, it's not actually that old. Suppose an investment pays 20% on a yearly basis. If you invest 10,000 per month, what will it be worth? What was the effective monthly interest rate? So because it doesn't talk about compounding, your formula would be the exponential growth. So I'm going to plug some stuff in. The amount after time passes is the principal of 10 grand times 1 plus 0.2 to the t. Now the way this is written is that t is in years because you used a yearly basis. You know, if you wanted to put 1 month in here, you would be like, oh, that's a 12th of a year. Wouldn't you? I think you would. So why not just modify the equation? The amount after time is 1,000 times 1.2 to the t over 12. Now you can throw a single month in it. There's where your 1/12 fraction would come with. And while you're at it, you can do the things I've been telling you. You can move that 1/12 to the interior. And the reason you're going to do this is because it's also going to give you that. That's why you do it. So you take your little 1.2, you raise it to the 1/12th power, and you get this funky decimal, 1.0153. Now, this piece corresponds to that piece. So 1 plus r is 1.0153, which means the r value is 0.0153, which means your monthly rate is 1.53%. Now I did round this, but if you take 1.53 and you multiply it by itself 12 times, oops, sorry, I gotta use a decimal. And I actually have to use 1.0153, and you raise it to the 12th power, you get 1.2. Anyways, how much money have I got? Well, I guess I need to plug a 1 in here. Although, I don't know. You should be able to figure this out without doing that. But a 1 has to be plugged in there. All right. Should earn about $15.30 in interest. Let's see. It was it was 10,000, wasn't it? Should earn $153 in interest. Fix that. Fix that. 10,000. 1.0153 to the first. You should have $10,153. And you do. A lot of times I leave stuff off. Stupid hands just don't keep up with my head. Apparently I'm going to do 15 too. It says solve by factoring. There's a hint here. It says let u be 5 to the x. This is called a u method, u substitution. If u is 5 to the x, that becomes a u. Here's what's cool. U squared would be 5 to the x squared. So u squared is 5 to the 2x. So this becomes u squared. And now it's something easy to factor. Factors of 125 are 20 and 5. Sorry, 25 and 5. In order to add to 20, that one's positive, that one's negative, set equal to 0. Now, since u is 5 to the x, I'm going to go ahead and put it back in. And I'm going to use the cover-up technique and solve. 5 to the x is, negative 25, or 5 to the x is 5. Because I did the whole change signs, whatever. If you can come up with an exponent that creates a negative number, I'll give you $1,000 in cash. It has to be real. Okay? If you can create an exponent that makes a positive number negative. Let me reframe this. If you can create a real exponent that makes a positive number negative, I will give you $1,000 in cash. I will, because it can't be done. It cannot be done. It's impossible to do. There's no answer there. This one you ought to be able to answer yourself. 5 to the x is 5 to the understood first power. X is 1. And it does say check with a calculator, so why not check it? This was 5 to the 2x plus 20 times 5 to the x minus 125, and it was equal to a 0, so I put a 0 on y2. Zoom 6 it, and there's only one line. That's it, and it's at 1. But again, if you can come up with that exponent that makes a positive number negative, I'll give you $1,000 in cash. If you even think you can do such a thing, it means you don't know anything about exponents. It means you know nothing. A lot of kids are like, well, I don't understand why that's not true. Think about it. Even negative powers create reciprocals. That's what kids always say. Well, just make the exponent negative. No, that flips it. 58. This is find the area of a triangle. And I don't know why they put it at 58. It's supposed to be hard, but you're supposed to find the area of triangle QRS. That's this guy right here. Now, last I checked, the area of a triangle was 1/2 base height. I think they put it this far down because they think, oh God, if we slant the triangle, kids are going to miss it. No, you're not. Height is always a right angle, okay? Count up. You're counting from -5 to 3. The height is 8. Your base length, -4 to 2, is 6. So area is 1/2 a base length of 6 times a height of 8. That'd be 24 all day long. 59 is something we've been doing very recently. The first and second terms of a geometric sequence are A and AB. A, AB. Means the ratio is AB over A, which is just B. Now, you should also know your form for a geometric sequence. The nth term of a geometric sequence is the first term times r to the n minus 1. So I'm going to write my rule. The first term is A, the ratio is B, and I'm supposed to raise that to the n minus 1. I'm basically done with this thing. They want the 643rd term. A to 643 is A times B to the 643 take away 1. And 643 take away 1 is 642. Choice E. Number 60, another ACT question. Points A, B, and C are 3 distinct points that lie on the same line. Notice they do not say in order. They don't say that they're in order. If the length of A to B is 19 meters and the length of B to C is 13 meters, what are all the possible lengths in meters for AC? So I'm going to draw, and you should too, or I'm not going to give you credit for it, possible ways of arranging A, B, and C. The obvious thing that you do first is you think about alphabetical order. And what I'm going to do is I'm going to move A to the middle, then I'm going to move A to the end. So it might be BAC, or it might be BCA. B's in the middle, B's at the end. Oh, I actually need a fourth one. I should have, I'm going to swap these around. What I want to do is I want each of these points to be middle and ends. See, this was on this side, now on this side. This is in the middle, now it's over here. I'm going to put B over here. That moves everything. Those are the only three pieces you need of this. Then I'm going to throw on what they tell me. They tell me that A to B is 19 and B to C is 13. Well, if you add those together, that's 32. And they're hoping that's the only one you pick. They're hoping you weren't thinking about things could be drawn not in any particular order. Next up, they tell me that A to B is 19 and again, B to C is 13. This is nonsense. It doesn't make a lick of sense. That's not it. And here's the last thing you could do. B to C is 13, and all of A to B is 19, which leaves 6 for that little segment right there. So the correct choices are that A to C could be 32, or A to C could be 6. Choice H. And there's your 7-6 homework. I hope you enjoyed it as much as I did, because I really like the logarithms. Hope that helps you out.